Good evening, everyone. Okay, so let's start with today's session. Today we are going to discuss about functions and different types of, there are different multiple types of functions, right? Other than that, we will discuss about procedural programming. That is one of the phase while learning any programming language. Okay, so see, let's create a file. Okay, so we have seen a list and tuples, or we have seen list comprehension, dictionaries, set, right? We have seen the difference between list, set, and tuples, all those things. If you guys are having any doubts in any topics till now, please let me know. We will discuss the doubts first. If not, then we will move forward, right? So, okay. Yeah, so we are going to discuss about, I think we have covered everything: lists, loops, tuples, dictionary, right? Today we are going to cover function and recursion. Okay, suppose consider a scenario, right, where uh, we have a we have multiple lists, right? Suppose my list one with values, we have my list two with values, right? And suppose we have one more list with values. Okay. Suppose our requirement is to we have to increment each and every element list one. We have to add each and every element by 20, right? We have to increment each and every element by 20, right? Suppose another requirement is element of list 2. We have to suppose add 100 to each and every element, right? Another we have element of list 3. And what we have to do in list 3, we have to decrease each and every element, suppose by 80, right? Okay. So these are our requirements. Okay. So we have seen that we have seen multiple types of iteration in list, right? We can achieve this by using for loop, for index, in, range, length of. Suppose let's first do the my list one, right? So what is our requirement? We have to add each and every element by 20, right? So this, okay, not I, the index. This plus equal to, it is known as shorthand operator, right? See, if you will write a plus, sorry, a equal to a plus b, and if you will write a plus equal to b, both are same, both are treated as same, right? These are non, so this plus equal to or asterisk equal to, those are known as shorthand operators. Okay, so this will do the job. Then again we have another requirement for my list 2. We have to change, increment each and every number by 100, right? And for my list 3, we have to decrease each and every number by 80. Okay, now let me print the values. My list 1, 2, and 3. So this is how we will achieve our goal, right? Incrementing or decrementing the values and getting the proper output. Okay, so each and every values are incremented by 20, by 100, and each and every values are decreased by 80. Okay, Now guys, see, observe these three for loops, right? If you can conclude that we are doing the same operation inside these for loops, we are incrementing elements by some certain values. Value doesn't matter, just look it into the operation. Okay, we are performing the same operation but for different lists. Okay, this subtraction, consider it as adding minus 80 to the elements. That will be okay, right? We will again get the same values. Okay, so consider this as scenario. Suppose you have hundreds of lists, right? My list 1, 2, 3, 4, something like that. You have 100 lists, and you want to add certain values to each and every list. For those type of scenarios, you have to create multiple for loops, right? Here we have created a for loop for list 1, list 2, list 3. Suppose you have list 4, then you have to create a new for loop for list 4, then again new for loop for list 5. So how to tackle these kind of problems, right? So there is a new concept which is known as functions, right? So what is your code? What is a Python code? So Python is a block of code, right? Python is a block of code which receives some input, right? Python receives some input and it produces some output, right? So suppose if you are able to create such a box where you will provide a particular list, where you provide a particular list and a particular value to add to that list, right? We are providing two things, a list and a value, okay, for addition, subtraction, whatever that is. Okay, we are providing the values. There is a code written inside that particular block, a code written inside that block. Okay, and this after this code you will get a resultant list. That's it. See, this is what we are doing here. This is a code, right? We are providing it some input, that is our list. It is performing some operation, addition, subtraction, or whatever that is, right? And after that it is producing the result. Okay, now how to see, what I want to tell here, that this particular block of code, it is known as function, right? See, it is not dependent on only one list. You can provide many number of lists to perform the operations. Let me first give you an example. So this is the syntax to create a particular function. Def keyword, your function name, right? Brackets, and after colon, you will write your code here, right? Function code here. Now see, what do we have here? Suppose this is our code, right? Hmm. Yeah. Minus, minus, this should be A. Mhm. Okay. Consider that you have a my list, your list, and you have a integer value A which you want to add or do whatever you want. You want to perform any type of operation on that. Okay. And what we will do, so see, this this is what a function looks like, right? This first line, it is known as function declaration. Okay, this whole body with the first line, it is known as function definition, right? This particular body where code is written, this is known as function code, right? So in simple words, what is a function? So function is a block of code, right? Function is a particular block of code which receives some input and produces some outputs. Just give me a second, guys. Yeah, okay. Okay, guys, so see. So consider this as your block of code, and what are the inputs? A list and an integer value to perform operation. Those two are your inputs, right? How to provide an output in a function, how to provide a particular output. So let me do just print the list here, right? Okay. Now instead of these operations, right, instead of these multiple for loops, see, this is a particular function, our particular function box, right? These two are our inputs, right? So we have created a function, we have provided a code inside a function, right? Now, how to call this function, how to execute a particular function? Okay, so let's do a function call. This is how you should call a function. First of all, the name of the function. Inside that, what is the first input? It is a list, right? So pass a list, whatever type of list you want to perform on. Okay. Then the second one is a, expecting an integer from us, right? So provide 2, 3, 4, 10, whatever the value you want to add. Suppose it at first I want to add it to 20, right? Now if I will execute, see, look at this output and this first output. Both are identical, right? Now at least at second list, what was our aim? To add 100 to each and every element, right? And for list 3, we are adding minus 80 to each element, right? See, see, the outputs are same, right? But this repeated for loops, this multiple repeated for loops, right, were now written inside a single function. Okay, and instead of executing these many for loops, we are just making function calls. How to make a function call? The name of the particular function, the values you want to pass, provide as an input to that function. That's it, right? Observe the code. Just observe this. What, how to create a function? When you will know that you have to create a function, and when there is a requirement of a function, see, inside this for loop, what we are doing, we are performing some repeated operations, right? We are performing some repeated operations on list, that is adding some values, incrementing some values or decrementing some values. That's it. So we implement a function for repeated tasks, a task which is repeated again and again. So for those type of tasks, we create a function, right? And there are function calls. There is a function call. Now, functions are of many types. Okay. Suppose you have a function named display. Okay. And you just print hello world. So what type of input this function is taking? This function is taking no inputs, right? There is nothing written inside this small brackets. So the function is not taking any input. In this case, how to call a function? In this case, how to call a function? Just write the name of the function, and we won't pass anything, right? Because this function is not expecting anything, it is not taking any inputs. So that's why we don't provide any input, right? Now we will run it, we are getting the output. So depend on these criteria that function needs an input and function provides an output. There are 4 different categories of a function, right? So what are 4 categories? Suppose you have a function which receives an input, right? Which receives an input, but it doesn't return anything. It doesn't provide any output. Okay, it doesn't provide any output. Suppose you have a function it doesn't receive anything, but it may provide an output. Okay, a return output. Instead of providing the particular correct technical word for that is return. Okay, now there maybe there is a function which doesn't accept any input and doesn't provide any output, any return value, right? And there is one more function, the first function we have seen, which receives an input and which provides an output. Okay, so these are four different types of functions. Okay, we will discuss some of them. Let's see. Suppose there is a requirement, right? There is a requirement to create a function to add two integers, right? Add two integral values. The format, the syntax to write a function is def function name. Suppose my function name will be sum. Okay, a colon and your function code. So if you want to add two numbers, you will ask for an input, right? Input of A and input of B. If you want to add A and B, you ask for an input. So suppose this function takes an input A and B, right? And what it will do, it will just print the values of A plus B. That's it. This printing value, this doesn't considered as an return value of a function, right? This is not an return value of function. Okay, return value by I mean that this return value, this return value. Okay, so this particular print statement is not considered as a return value. Okay, whenever a function returns something, we use the keyword return, right? Okay, so how to provide a function call for this? You want to add two numbers, the first number is 10 and the second number is 90, you will get an output of 100, right? Yes, this output is provided by your function, this function, but this function is not returning anything, right? So the category of this function will be this first category. It is accepting values, input, but it is not providing any return value, right? Now, suppose there is a requirement to declare a sum to such that it won't receive anything. It won't receive anything. But when, okay, just the second category will be, okay, return statement. Let me think of a more reasonable example. Suppose you have a function named as my name, right? So by syntax, you will notice that this function doesn't accept anything, doesn't accept any input. Okay. Now this function just return a string, right? So what this function is doing, this function is not accepting anything, but this function is returning some value. So this comes in the second category, right? It isn't accepting anything, but it is returning some particular value, right? So suppose if this function is returning some value, we need a variable to store that return value, right? If this function is returning this string, we need a string variable here to accept, to catch this particular string, right? So a function call for a function which returns something is written like this: a particular variable to receive, to catch that particular return value, and just call the function, right? And let me print the name. Okay, now this is the third condition. So we have seen the third condition here in the display, right? This particular display function is not accepting anything, right? There is no input provided to this display function, and this display function is not returning anything. So there is no return statement inside this particular display function. That's why this comes under the third category. Okay, no input, no return type. Now guys, there are some particular technical words for this input and this return types, right? Okay, so whatever type of this list, this inputs we are accepting, there are technical terms for this. So how to create a function? First of def, then your function name, then these inputs, these are known as parameters, right? In function, these inputs are known as parameters. Okay, and the return value, this return value, this is only known as return value, right? Nothing else. But particular this function calls, right? What this function call consists of your function name and the values you pass as an input to that function, right? This list and this 20 is the value you pass as an input to this particular function. So these inputs are known as arguments, right? These particular parameters are also known as actual parameters, right? And these arguments are also known as parameters, or you can say argument parameters. Multiple names are there, but we will use arguments and parameters. That's it. Now, see, you have seen the use case of a function, right? If there is some operation which are in repeated terms, right, which will be executing again and again. So in those cases, we will create a function, right? Okay. Now there are some theory related to these functions. Suppose you have multiple functions created for some operation, right? There are some operation 1, some operation 2, some operation 3, and some operation 4. You are a user. Okay, you are a user. So if you want to perform operation 1, you call function 1. If you want to call operation 3, you call operation 3. That's it. So when there are multiple functions are already created, okay, if there were multiple functions exist, right, and your work is to only call those functions to get your job done. For example, if you guys have ever heard about SQL, right? In SQL, you use a select keyword to get each and every data from your tables, right? In calculator, if you guys have used calculator, then you use the plus to add two numbers, subtract two numbers using negative sign. That's all. So in MS Excel, you have used multiple formulas there, right? So whenever you have used a particular function to get your job done, those type of programming, those type of structures are known as procedural programming languages or procedural programming structures. There are multiple procedures. These are known as procedures, right? So there are multiple operations were given. You have to just press a button to execute that operation. That's it. Okay. Yeah. Now, okay. So let's modify this first, our first example, right? So right now what this function is doing, it is accepting some values. Okay, it is accepting some parameters, but there is no return statement inside this function. Okay, so it comes under which category? This particular one, this category. So this is also known as, just some simple English words, right? Uh, with parameter, no return type, right? So this function is an example of with parameter, no return type. Okay. So now I don't want to print my list here, right? I don't want to print my list inside the function. What I want this particular function to return my list. Okay, so if the function is returning some values, what we need some variables to catch those values, right? We need some variables to catch those values. Okay, in front of this it will be 2, front of this it will be 3, right? So operation on list is returning some values and we are catching those values in mylist1, mylist2 and mylist3, right? Now this is a proper example of with arguments with return type, right? Did we have seen with argument? Okay, so we have not seen any. This example is without arguments with return type, right? This is an example of with a return type, right? Okay. Now let's move forward. So you have seen the use case of a particular function. From day one, we are using multiple types of function if you guys have noticed, right? See, whenever you are using print hello world, this print is nothing but a function itself defined by Python, written by Python, right? Not by us. These are known as user defined function, the function we create, and these type of functions are known as predefined function, right? They are already present there. If you will press control and hover over it, just click and it will give you the implementation. It will show you the code written inside this print statement, right? So let me this particular print. See, this is the particular code written inside that print statement, right? No need to just understand this code. Just try to understand that from day one we are using multiple types of functions, right? That's it. Okay. Other than this, we are using function like length. We have seen that my list one. So what it will print? It will print the length of that particular list, right? So these are types of functions. We have seen these type of functions, right? There are many more functions. Suppose there is a module named as math in Python, right? And there is a function inside that math module that is known as a square root. If you want to print square root of any number, right? I want the square root of 5. Just pass that number inside the square root and you will get your answer, right? So what is this square root? This is nothing but a particular function. Okay, see, this square root is nothing but a particular function. Okay, and where does this square root is written? Where does this function is? See, this is a user defined function operation on list, and where it is defined? It is defined inside d3.ipynb file, right? So this square root is also a function, and where it is defined? It is defined inside this math file. Okay, see, the name of the file is math.py, right? And here the square root function is written. Okay, so okay guys, one more thing. Have you noticed the extension of this file? It is pyi, not py or not ipynb. It is pyi, right? There is a difference in these. See, we have one more file that is named as pyc. Okay, so we will discuss about that later, right? Right now, let's focus on the methods, functions. Okay, square root is a function. We have seen that we have more such functions, right? We have the deep copy is also a function. From copy import deep copy. So what is this deep copy? This deep copy is also a function. If I want to copy, suppose my copy list, and I will use deep copy. I want to copy my list one into it. That's good, right? Okay. So deep copy is also a function, right? So these are many functions in Python. These are predefined. Okay. If you want to see the implementation is written inside copy.py file. Okay. See, here the extension is .py, but during math, when we are using this math, the uh, the extension is .pyi, right? So there are differences, guys. We will see about that. First of all, so this is how a function works. Print is a function. You are writing the function name, passing some arguments to it, right? Passing some values because print is expecting some values. See, not here. Let me show you. Okay. See, this print is expecting these many values, these four or five values, right? If you have remembered that, then when we are using end equal to some space, the change of new line is not there, right? The gap in the print statement is indicated by a space only. See, there is a variable named as end to receive a particular, a particular argument from the user, right? Now, guys, yesterday we have seen that it is a good practice to indicate the type of a variable in Python because of suppose this is a function, it is created by you, right? But this is a print function which is created by someone else, and I want to use this print statement. So see, with each and every variable, they have written the data type of that variable, what type of data type that variable is expecting, right? So it is a good practice to follow these, right? Inside this list, what I want, yeah, inside this list, what I want, it is a type of a list. So I will just mention the type of the variable, right? What is this? This is a type of an integer, right? Just keep me. Okay, guys. So see, so these are just good practices, right? Now, it is not bounded that you can only provide a list there, right? Okay. So now we have seen in build function, we have seen user build functions, right? Okay. Now let's create a very small project, right? In this project, right, we are going to discuss about, let's say, let's use a particular file. Okay. How many of you are comfortable with the OS module of Python? There is a particular module, the particular library in Python that is known as OS. Okay. This OS library, it helps you to interact with your operating system, right? If I will print, yeah, it will be, see, there are, okay, let me give you an example of first the commands. See this cd, this particular cd command, it is used to get into some uh, directories, right? Inside some directories, if I will press d and colon, it, see, right now I am working with my uh, c volume c, right? But if I will give this cd d colon, it will get me into this particular d directory, right? So how to do that? Wait, see, right now I am inside our my d directory, right? Okay. Now there is some one more, that will be dir, right? It will list all the directories in your particular volume. Directories means folder. Okay, by directory I mean folder, right? So it will list all the directories, right? Okay. If you will press pwd, so what is this pwd? Pwd will tell you your current path where you are working right now, right? See, if I will do, suppose I want to get in inside into this cpp library folder, right? So let me show you folders. See, inside local disk d, I have these many folders, right? And see, all those folders are listed here, right? If I want to get into this particular cpp folder, right, just pass cd and the name of that particular folder. Okay, right now I am inside this cpp folder. If I will give you the particular directory view, these are the directory, right? So these are some few particular commands, right? So you can imitate those commands from python using os direct, using os module, right? Suppose, okay, so there are, okay, let me first print this one. So this get cwd, it is similar to that pwd we have just seen. It will give you the particular directory where you are working right now, right? I'm inside my volume d workspace, a python folder, inside that another python folder, and then dash 5, this get cwd, right? Okay. Now suppose, okay, now let's work with uh well, let's not make this more complicated. First of all, let's finish the methods, then we will get into a simple project. First of all, let's create a particular method, a particular function, right? What that function will do, you will provide a very larger string as a input. As a user, you will provide a very large string. Okay, let me write that. User will provide a large string, right? What is your work? You have to write a function to break that string into each word, right? So this is your work. For example, if I have provided hello world as my string, this whole hello world is treated as a string, right? If I have provided this, then what you have to do, you have to convert this hello world into a list of strings. The first element will be hello, the second element will be your world. So this is we have to do this, right? Okay. See, one more thing. There is a space, right? So that space will be also counted as one more element. Okay. So this is you have to achieve, right? First of all, let's ask for the user for its input, right? So let's create a variable myString. Okay. First of all, let's ask the user for an input. So this time enter, right? One more thing, guys, there is no need for typecasting here. Why? Because we want the user to insert a string only, right? And input. See, input is also a method, also a function, right? As a print, or as we have defined this operation on list, input is also a function. Okay, and by its calling structure, a syntax, you can observe that input returns something, right? See, we have called a function which returns some value. To accept that value, we have created a variable. Similarly, what this input will do, it accepts some values from your command line. Okay, the values you enter here, right? And it will return back that values to your particular variable. See, this is the input. It is expecting something, right? Some parameters are there, right? Okay, let's work with this. First of all, print your string. It will show what we have get as a string. Now, what is our requirement? We have to break. Okay, so we can do that in one line, but right now we are learning function, so we will do it using a function, right? We will create a function for that. Let's create a my string list here, right? And suppose we have a function named string to list, and what we will pass my string. We have to create this particular function, and what this function will accept, this function will accept a string. Format this. Yeah, so we are halfway there. We have the skeleton of the code, right? See, I have uh, written a keyword here, that is pass, right? If I will remove this keyword, we got an error. Okay, so if you want to create only a skeleton, you don't want to provide any code there, right? It is necessary to provide a code inside your function, right? Otherwise it will get, you will get an error. So if you don't want to provide a code there, just use the keyword pass, right? Okay, so we have a skeleton there, right? What we are expecting, we have created, suppose we have created a particular function, we will pass the string, and this function will return a list of a string break into words. Okay, break into words. Okay, suppose, now let's work with this. So do you think, is this the correct conversion? I mean, is there is any need to store this particular space? It will be meaningless, right? Our aim is to convert that particular string into a list. So storing a particular space will be meaningless. So to achieve this, either you can go with a particular, okay, let me see. So either you will go with a for loop, or we have a predefined function here, right? A predefined function. You have seen append and clear, remove, sort, all those function with list. There are some functions which are there, some operations, some methods of strings also, right? So if you want to convert a string to a particular list, how to do that? Suppose I have a variable named my list, and what I want, see, we are accepting input into this, only this variable, right? So that particular variable into dot, we use the particular function split, right? And what is the work of split? Okay, let me show you the work of split. Okay, it is asking me for some values. See, this particular thing is achieved by using only a simple single line method in string, that is known as dot split, right? So okay, right now we are not returning anything, right? So if I will print the value of my string list, if I will print the, see, we are not returning anything back from this function. So this string list is not receiving anything, right? In this case, what we will get the value as, we get the values as none. In Python, none means nothing, void, right? A blank space, nothing. Okay, none means nothing, right? And remember one more thing, for a false condition, 0 is considered as a false in Python. False statement is itself considered as a false in Python, and none is also considered as false in Python. If you have remembered, we are using if, right? So if you will use none inside if, this is considered as a false condition. Okay. Now, yeah. So now we have to, instead of printing it here we have to return this list, right? So right now, what my function is doing, it is breaking the string into list and it is returning that particular string. So we can do this multiple times as we please, right? Suppose I want to repeat this particular thing 10 times. Okay, so instead of doing this, let's write while, not while, for I in range 10, right? So instead of index, I'm using an underscore. So consider it as a standard practice, because there is no need for this particular variable inside my code, right? I just want a loop which will run for 10 times. That's it, nothing else. Okay. So if we will execute this one, see, first time it is asking me for an input. Let me provide hello world. How are you? Now notice, if I will provide a trailing space, it means if I will provide a space at the starting index, here I have provided 4 spaces there, right? After that, if I will provide a particular string, then after that also I will provide space. We won't get any output here, right? For that particular hello, I didn't get any output. Also see, I'm providing 2 spaces, right? And after the input, I'm not providing any space, right? See, we are getting some input, but this input, see, for the hello, we are right now we are getting the input. How are you? Right now we are getting the input. If I will provide, see, observe this input, I'm providing 4 spaces, right? I'm providing a string, and I'm providing four more spaces. See, right now we are getting the output. Okay. So let me end this one. Yeah. Okay. So suppose to handle these type of cases where you have some trailing spaces, right? If you want to clean your string, if you want to remove this particular space, right? What we will do, we will use, just give it a second. See guys. So right now we have a condition inside our function, right? And what is this condition? See, what I am checking, the first particular value of my string, right? That if the first value of my string is space or not. If it is a space, then what I am printing, there is a trailing space in my string. So that particular string is not a valid string and I am returning a value. I mean, I'm returning nothing, right? So instead of 10, let me take it as 3, right? Now execute. This will be good, right? See, now I am providing 4 spaces. See what we get? Trailing space is there, and inside our my string list we are getting nothing, that is none, right? This hello world is printed because of this print statement. We are printing my string, that's why we got that particular print hello world. Okay, now if I have some string and I have space at the last, nothing to do with that, we are not checking that, right? So there is one more particular function to remove these trailing spaces from your string, right? To clean your string, that is known as strip, right? What is the use of the strip? It will remove the trailing spaces from your, see, input will be displayed after your code block in .ipynb. Okay, increase the size. Yeah. Okay. So what is the use of this dot strip method, dot strip function? So what it will do, it will remove the trailing spaces from your particular string, right? What is the use of split? It will break your string into multiple different words of list, right? So we have seen, okay. Now split doesn't only break your string at particular spaces. You can provide any argument inside it, right? You can provide where to break your string. Okay, let me give you an example of that also. Suppose I have a list, right? And I want to split. Suppose I have a string, temporary string with value. Okay. Suppose I want to break this particular temp string into the places where E is there, right? I want to break from there. See, what this split is doing, it is breaking the particular string in between from the spaces, right? If there is a space, it will break that word. Okay. So what I want the particular split to break from where it gets that E character, right? For that, this will break. Okay, let's see the output. We'll get, see what it is doing. It is breaking the particular string from wherever it will encounter E, right? Now it is not only restricted to a particular character. You can provide a string also. Suppose I want to break the string whenever I will get a EL together, right? See, in this case, it is breaking the particular string wherever it is getting EL together. Okay, I want to break the string wherever I will find ERE together, right? See, the string is divided into two string because only there is only one place where ERE is there, right? So split can also accept particular values. Similarly, strip can also accept values, but Strip is generally used to clean your particular string to remove the trailing spaces in your string, right? Okay. Okay. Now guys, let's discuss about a very good practice of taking inputs in Python. Okay. So suppose yeah, suppose you are expecting a user to provide you an input, right? An int. So let's convert that input to int, right? This is okay, right? So I am a user. The program is asking me to enter a particular integer. What happen if I will provide first three spaces and after that I will provide a 12 and after that I will provide multiple spaces. Okay. In this particular case, what happen if I will let me print the value of a. So in this case, what we are getting a as 12, and what is the type? The particular type of a. So this particular type is taken as int. So how is this working? So the similar concept of working with a mm, strip, the similar concept of working as a strip is working there, right? These trailing spaces were removed, right? And after that, this particular value is taken as an integer, right? Okay. Now let's say different type of function calls. See, we have seen basically four type of functions, right? Now there is two different type of function call, how you can make a particular function call. Okay, suppose I have a function and the work of this function is to add three different numbers, right? And what it will do, first of all, let's use formatting. Okay, now how to call this particular function? So this particular function is not returning anything, right? So we don't need any particular variable to catch the values, right? We just have to pass the values. Okay, see, okay, observe this code very carefully. This particular 10 is received by A, right? This particular 20 is received by B. This particular 30 is received by C, right? This is how values are passed from function call to actual parameters. A, B, C are parameters. 10, 20, 30 are our arguments. So 10 is passed to A, 20 is passed to B, 30 is passed to C in a sequential manner, right? But suppose I don't want it to follow a sequential manner, right? I want that B will accept 10, A will accept 20, and C will accept 30, right? Now if I will call, see, A is accepting 20. If 20 is written in the second, in the argument list, 20 is written in the second position. But then also A is accepting 20 as its input. B is accepting 10 and C is accepting 30, right? So this type of call are known as parameterized function call, right? And these are simply known as function calls. That's it. Okay. Now observe one more thing. Instead of the actual variable names which are declared here to as a parameter, if I will pass any other variable name in these cases, see what happens. I will get an error, right? Because D is not an argument. Unaccepted keyword argument D, right? So you have to pass the exact same word, exact same name of the particular argument which is accepting the values, right? Okay. Now come back to print statement again. What we have, hello world, and with end, what we are passing, a space, right? What is this hello world is? This is a string, our argument number one. What is this end equal to space? This is our argument number two, right? Now let's observe this particular print statement, print function. Inside this print function, there are many values, right? Many parameters to accept values, but we are specifically targeting end, right? And see, there is the particular variable name end is present there, right? Instead of end, if I will pass any other name, we will get an error, right? Okay. Now guys, observe one more thing. For this particular variable, I don't need for this particular first argument, I don't need any name, parameter name to pass the values, but this last we need a parameter name. What happen if I will write this first, right? In this case also we will get an error. Now let's observe how we will get this error, right? So see, we have seen that during parameterized call, the sequence doesn't matter, right? Wherever the values you want, just be careful with the name of the arguments, the name of the parameters, that should be exactly same, right? But what happen if you want to pass the some values as traditional function calls and some values as parameterized function call, right? Suppose I want to call sum3 and I want to pass 20, I want to pass 89, and I want to pass C 3, right? It will be good to go, right? There will be no problem with this. Okay, but instead of the last argument, if I will write a parameterized call for any of the middle argument, we will get an error, right? Now, why this error? Think logically. This 20 will be passed to this A. This 89 is meant to be passed to this B. But what we are doing, we are assigning that 89 to C, right? We are assigning that 89 to C. So the last parameter got its value and the function call will end here, right? We won't provide any value for B. B won't receive any value. This 43 is not going to be received by B, right? So it is necessary, it is mandatory, right, to write your parameterized call at last. See, positional argument follows keyword argument. This type of parameterized call should be written at the last, right? In this case, there is no meaning to write a parameterized call for C, because if you won't provide any C, then also this 43 is going to be passed to this C only, right? Okay, okay, let me provide you the example of the error also. Good for minutes. If you will provide a A here, also you will get an error for 89, right? Okay, guys, one more thing. Suppose instead of 20, if I will provide A equal to 89, right? We are not getting any error here right now. But if I will run this code, we will get an error, right? Error line number 10, this particular line. And why this error? See, what we are expecting. We are providing A with the value 89. We are providing C with the value 43. What we are thinking that this 20 will be transferred to this B, right? But it is not going to happen. Okay, this particular 20 is going to be assigned to this A and nothing will be assigned to this B. See, we got an error that multiple values of argument A. They are getting multiple values of A. The first value will be 20 and the second value is treated as 89. Right. So Let me provide you this error also and one more one, this type of error also, right? Okay, guys. Now there are no errors. Okay. Now come back to print statement again. See, there are multiple parameters are there, but we are only providing values to two parameters, right? Only two parameters. The first parameter is this asterisk values, right? And the other parameter we are providing is this end, right? But these we are not providing separation, we are not providing file, we are not providing flush or other things like that. So why we are not getting an error in this case? See, if I try to call this particular sum, suppose I try to call that particular sum3 with only two arguments, 10 and let's take C as 89, this type of argument. In this case also we will get an error because the number of C missing one required positional argument B. The code wants us to pass the value for B. It is mandatory, right? So why this? See, printf is also expecting us to provide how many arguments are there? 5 arguments. But instead of 5, we are providing only 2 and it's okay. It will run. No problem with that, right? If you will provide only one argument, that's also good. It will run with that. Now, how to achieve this type of functionalities, right? Now, let's take one more function and this time it will sum 4 elements, right? Okay, that's good. Now, in this case, suppose I leave the number of arguments, the number of input on the user, right? It is up to the user if he wants to provide two values, two arguments, or three arguments, or four arguments. What I mean to say that if the user will pass only two arguments, I'm okay with that. I want my code to run with this value also. If I will provide the function with three values, I want my function to run with this value also. If I will provide it with all four values, I want my program to work with to run for these values also, right? So I want to create a function which will add two elements, three elements, or four elements. Right? I want to create this type of function. So how to achieve these type of functionalities, right? First of all, if you are providing only two values, this 10 will be passed to this A, this 20 will be passed to this B. Okay, C and D will be going to be empty and we were getting this type of error. Let me show you that error again. In this case, we are getting a missing two arguments. See, missing two required positional arguments C and D. We are missing C and D for this particular function call, right? Now, how to bypass this, right? So, this particular value, suppose what I want, if user will provide you two values, I want to add only those two values, right? For that type of condition, what I want that the value of C will be 0 and the value of D will be 0. So this type of this writing style, this particular syntax providing a value in parameter is known as default parameters. This C and D are considered as default parameters. Now see, in this condition, all four will work. Now how come this is working, right? See, when I am providing 10 to A, 20 to B, see, observe the values. The value of A is 10, the value of B is 20. The value of C is 0, the value of A is, oh, I have written A here, right? Okay, value of D. The value of D is 0. So why we are getting two zeros here? Because we have provided some default parameters to default values to these parameters, right? Now, what is the need? What this default values will do? So the definition of this default parameters are: if nothing is provided from the user, if no values are provided from a function call, consider those default values as your value inside function. I am not providing anything, so C will take 0 as its value, D will take 0 as its value. Now come to this second function call with 10, 20 and 30. Right now I am providing some value for this C. Right, I am providing some values for C. So in this case, C is taking my particular value provided by the user, value provided by the function call. C will take that value, but I'm not providing any value to the D. So D will get its particular default value, that is 0 only, right? In the third condition, we are providing values for all four parameters. So in this case, all four parameters will receive their own dedicated values, right? So this is how a particular default parameter function calls works, right? Now let's try to mimic the particular function call for that print statement, right? Suppose I want to sum the elements. I am passing value for A, I am passing value for B, but instead of C, I want to pass value for D, right? See what we will get. There is no error and we will get an output. Why? Because we are not providing any value for C and C is getting 0 as its default value, right? So there is no problem with that. Okay. So this is how we are trying to mimic. Now let's see some error prone calls, right? Suppose we have some 4, we have 10, right? And we want to provide D with the value 80, right? Okay. What happened during this call? We will get an error, right? Now, why this error? B, A and B are not default parameters. So it is compulsory, it is mandatory to provide values to non-default parameters, right? See, missing one required for positional argument for B. This 10 is transferred to A, no problem with that. But no value is transferred to this B. This B is empty right now. And B is also not a default parameter. So in this case, it is compulsory to provide a value to B. So what we will do, we will make each and every argument as default parameters. In this case, each and every function call will work. If you will not provide anything, then also each and every function call will work. And the values will be 0. Why? Because we are not providing anything. So this A, B, C, D all are working with their default values only. See, all values are 0. So each and every A, B, C, D are accepting their default values only, right? Okay, so the observation here, right? First thing, it is not mandatory to provide default values, right? It is optional. See, if you are not providing any default values, then also your code will work, right? This our code is working, right? But it is a good practice. Sometimes it is necessary, sometimes it is a good practice to provide default parameters because you are taking inputs from user. So user may provide 2 values, 3 values, 4 values, or 1 values, or no values, right? Okay. Other thing, it is mandatory to provide values in function call if you have some non-default parameters, right? Okay. Now, as we have seen error in these three conditions, right? Similarly, there are errors in default parameters also. Suppose if I won't provide any default values to this D, we will get an error, right? Why this error? Suppose what happened, consider this call only, sum 10, 20. What we are expecting, this 10 will be passed to this A, this 20 will be passed to this D, and B and C will get their default values. But this is not going to happen, right? This 10 will be passed to A, 20 will be passed to D, C will be empty, which will be accepted, right? Because C is a default parameter. But for D, D is not a default parameter, right? See, if I will run this, we will get an error, right? And it is compulsory, it is mandatory to write all default parameters at the end of the list, right? If I won't provide any default value to B, that's okay, it will run. So if you are providing any default values, write those parameters at the end of the code, at the end of the parameter list. Okay. Now everything will work fine. That's good. We are getting an error. Why? Okay. We are getting an error because A is not a default parameter and I have made a empty function call, right? Remove that one. Need for that. See, it is only simple logic that if you are creating a function to perform some sum operation, user should provide you at least two arguments, right? For addition, subtraction, or whatever that is. Okay. Now let's come back to print again. So we have seen that why we are not getting any error if we will provide any end, right? Not the all seven values, right? We have seven or five. Yeah, all five parameters are there. So we have seen that those five parameters are default parameters, right? See, the default value of separation is space. The default value of end is slash n, that is change line, which is by default taken in print, right? We have seen that. The default value of file is none. The default value of flush is false, right? Okay. Now instead of zero, you can also provide none here. What does this none mean? This means nothing. Sorry. This none means nothing, not even zero, a blank. Okay, nothing means not even zero, right? We are getting a call for, yeah. Okay, that this particular error is for some other reason, right? You cannot see, we are performing an addition here, A plus B plus C plus D. You cannot add none to anything because none is an empty space. Consider it as a vacuum, empty space, nothing is there. So you cannot perform any operation over none, right? So in mathematical terms, take it as zero. In case of string, we will take that as a particular none or something else, right? Okay, we are talking about print. See guys, they have provided the particular, you can say signature, right, of the arguments. It is a good practice, right? Always provide what type of value you are expecting the user to input. What type of value you are expecting the function call to provide, right? Okay. And how to see, we have provided the types of input we are expecting, right? How to provide the type of input you are going to return. So provide, write an arrow, and in this function we are not returning anything, so I will provide none. 2%. So I will provide none. In this case, where we have some case, yeah. In this particular case, we are returning a list. So in this case, what I will write, a list. Okay. So you are not bound to write these things, but as I told you that these are some standard practices, nothing else. Okay, yeah. There is one more thing, that's this separation. Okay, let me show you a use of this. See, Let me remove this. Hmm, okay, I don't think we are getting that. Leave this one right now. We have file, we have plus. Because I think, do you any of you have any doubts regarding function and function calls? Also, let's talk about recursion then. Now, up till now, what we have seen that we are making a function call, and that function, after completing its execution, will return back to this particular line, and after that line, other line will start executing, right? Let me show you a visual representation of that. I have some sample. Okay, only take on this example only. Okay, so right now we are going to discuss some theories, right? Return, return inside function, return value, print my list. Okay, start the debugger. Yeah. So, okay, guys. First observation. Okay, at line number one we have some code. At line number two we have some code. At line number three, four, five we have some code. But our execution always start from a statement, from a particular line, from a particular line of code which is written in main, right, which is written without indentation. For right now, for starters, only consider that which is written without any indentation. Okay, that is the first line of code which will be ever going to be executed, right? Okay, now all these particular function, these particular lines statements are written inside, also written inside a function which is known as main function, right? It is not mandatory to always provide a main function in Python. Okay, you can consider it as that these things are written inside a main function. Okay, you can consider that, right? Now, there is a very popular statement that the execution of a code always starts from a main function, right? Okay, so execution starts from main function, our first line which is not indented, right? Our first line, that is line number 8. In line number 8, I am asking for user input, right? See, the prompt is there, enter your string. So suppose my string is, that's it, right? I print enter. The second statement is print statement. See, we have a variable my string hello world, my string hello world, right? Inside global, do we have any? Leave this. Now, the second statement is print statement. See, the hello world is printed here. The third statement, in this time, what we are going to do, we are calling the function. So observe the flow of your interpreter, how it is going to jump back to that function, right? See, it is jumping back to that particular function. And what is the value of this my string? The value of that my string is hello world, right? Because we have passed hello world to that particular string, right? Okay. One more thing, observe this call stack. We have a string to list. The name of this function is here, right? The first function is your module, which is your main function. Uh, After that, we have a string to list. At day one, I have told you that there are multiple types of memory, right? One of those memory is known as stack memory, right? Suppose it is your stack memory. And what is the use of that particular stack memory? It will arrange your function calls, right? It will take care of your function call, which call is executed first, which call is to be end right now, which call is to be exited right now, right? It will take care of that. Now we are inside the function, it will perform strip, then split. Then see, we are at return. Now observe this line number 5. Okay, and note one more thing. Whenever a return statement is encountered inside a function, the execution of that function will end then and there only, right? The execution of this function will end at line number 4 only. We are not going to execute line number 5 or any line after that, after return statement, right? See, after that return statement, we will come back to line number 11. Line number 5 is not executed. Now, observe one more thing. The function is called from line number 11 and we will come back again to line number 11, right? We are going back to that particular line from where function call is made. Okay. Now, what this function is returning, this particular function, see, this function is returning a list, right? A particular list of values, right? Okay. Now, after this function, what we have a print statement. We have to print the values. Observe here, right? We will get the outputs. See, we have the output and the function call ends, everything ends. That call stack is deleted. Each and every memory space which your code is taking was deleted, right? So this is how a function call works, right? Now, suppose, so what, give me, yeah. So from our observation, we have seen that there is a line for function call. This function call calls the function and this function will return back to that function call, right? Now consider a situation, right? Suppose you are inside a function and after few lines of code, right? At last there is a function call. Inside a function there is a function call, right? And what this function call is, this function call is calling itself only, not other function, itself only, right? So when this function call itself, what happens? Inside the memory, you will get a copy of this function, right? It is theory, guys, so just have some patience, right? So what happened? It will call this particular code. Execution will start again. Then again in the end, there is a particular function call to the same function and it will call the function again. What we will have here, we will again have a copy of this function. Okay. So let me show you what it is right now. It's what's going on. Suppose, first of all, let's see a use case of a function calling a function. Uh, okay, let me take this example only, right? And yeah, remove these things. Just return a plus b plus c plus d. That's it. And not also this. Let's call a display function with all these values. And suppose we have a display function here which accepts some value. Suppose the name of the value is some and some, right? and let it print that particular value. Let me define the type, that will be integer. That's it. Let me provide a function call for this, right? In this case, we will get the value particular 10, right? Okay, guys. So consider one thing here, right? What this sum for? Okay, not here. Let me provide you a debugger for this also. Yeah. Now, what we are doing, we are providing a particular sum function call, right? With values 1, 2, 3, and 4, right? Okay. So now we are inside function sum. The value of A is 1, B is 2, 3 is C is 3, and D is 4. We have all these values assigned. Okay, it's good. Now from observe this call stack. From sum, we are calling again display. See, from main function we have called sum. From sum we are calling display, right? And what is the value we are passing to display? The summation of all those values, right? So what is right now what's happening? Suppose this is your function 1, right? We have called this function. There are some lines this function has executed, some line of code, and there is one more function call here, right? We have called that particular function also. We have made a function call to this function. What this function will do? It will again execute some code, and after executing each and every line, it will come back to this line only. Right? Observe this. See, we in the stack we have a display. It means we have two functions in the stack. Our call, the first function one and function two, and function two, right? Now make a function call after executing. See this after this display function, we are going back to sum, the function sum. After completing this particular function, we are going back to that single line, that line from we got the function call, right? And after this particular function we will come back to the function call from this where this function is called. So from this function we will go back to this line only, right? So this is how a consecutive function call works, right? You call a function from a line, the function will come back to that line only. That's it, right? And after this execution the function ends, each and every memory is deleted, right? Now instead of doing this, consider instead of calling display, you are calling sum for the function itself, right? Okay, you are calling the particular function itself. So let's remove all these. There is a particular function. From this function you are calling the function itself, right? So let's see what's happened, the particular memory structure, how it's work. We make a function call, the values of a, b, c are there. We have the sum function at in our stack. Now again we call the sum function and we pass only one value, right? The summation value, and that summation value is provided to a. All other b, c, and d have got their default values, right? See, why my brightness is going like this? Okay, a second. Yeah. Okay, so observe this call stack. There is one more function called to the same function, but there is one separate memory for that function, right? See, so instead of calling that function again, what this function will do, it will call itself again by creating a replication, a replicated memory, a copy of itself, right? Now see, inside that function, again we will encounter this particular line. It will again call itself. So what happened? We will get again a particular call, function call. So what happens? Inside this function call, again line 1 is executed, line 2, 3, 4. At the end of the line, again we will get a function call to itself. So what it will do? It will again call a particular function. Then again there is a function, right? Now see, again after that, the function call itself, again the function call itself, right? So these many function calls we have. What happened after this? Again this function executing the lines. This function will call itself. That function will again call itself. That function will again call itself. There is no end to this. Now we are stuck inside a recursive infinite function call, right? This is an infinite function call. It is never going to stop until unless your RAM memory will go out of, you can say, space, right? There will be no extra space remaining in your RAM memory. Okay. Up till then, I think this code will run somewhat around 10 to the power 16 times, right? So this is recursion, right? This is how recursion works. It will call it if the function call itself, that type of function call, that type of arrangement is known as recursion, right? Now how to control this recursion, how to control a condition, how to control a recursion such that after calling the function certain number of function certain number of times, the function will come back, right? The function starts going back. There is a return statement from where the function will go back, right? So let's see how to design a recursive function. So we have seen the particular scenario where there is a loophole in recursion, right? A particular hole where the recursion may go up till infinity, right? So how to uh, design a particular recursion? Suppose you have a function. Now again, how to observe that the function is going to be a infinite one? There is no return statement inside this function, right? So again and again this particular line will call itself. We will get a replication like this and it will go till infinity, right? Okay. Now we have to add a particular base case. Whenever you are writing a recursion, at the top, at very first line, include a base case, a case where your function will start returning. Suppose I am adding a case where if n is double equal to 0, if this input number, this parameter n is 0, I want my function to return back. I don't want my function to execute from there. I want my function to return back, right? So this particular case, this is known as base case, a particular case from where your function will start returning back, right? Okay. Now let's try to execute this function. And here we have call 5, right? Okay. Okay guys, so in this case we are going to observe multiple things, right? First of all, some things are your Python recursion and all those. In this case, we are also going to observe what is a global and a local variable is. A global and a local variable, right? Okay. Now, we are at our function call, right? We are making a function call. Mm, See, until line number 8, there is no variable n is defined there, right? There is no n exist for this code until line number 8, right? Now come here. Now we are inside our function call. Now n suddenly n exists. Inside this function call n exists. Why? Because n is made here, a new variable n, a new parameter n is created to receive the upcoming value. A new variable parameter n is created to receive the upcoming value, that is 5. So see, n is our local variable, local to this function only. In our entire code, this function is the owner of that n, right? This n will exist inside this function only. Outside this function, there is no n, right? So that particular n is known as local variable. Whenever you will create a variable inside a particular function, we have seen many examples. See, this a, b, c, d, all are local variables only. We have multiple examples. This my string, this my list, all of these are local variables only, right? So whenever we are inside a function, whenever you create a certain variable inside a function, those are considered as local variables, right? Local variables only exist inside their parent, inside their owner, not outside their owner, right? Okay. So we have n as 5. We will check the condition n double equal to 0. That will be false. We will go to line number 5, which will print the value of n. That will be 5. Now we are again calling the function, right? So what we are doing, we have a function call, we have a function call, we have a function call. Now, in this scenario, the value is 5. We are again making a function call, right? It is a recursive call, so we are making the function call to the same function only. But what is the statement of function call? It is n minus 1. So this particular n is local to function 1 only, not to function 2 and not to function 3. This function 2 will also create a n for itself, and the value of this n will be 4, right? Because we are passing n minus 1. Again, this function call will provide a recursive call. This function will also create a local variable n for itself, and the value of this n will be 3. Now let's observe this, where we have, yeah, observe this call stack, right? Observe this call stack, observe the value of local variable, right? Okay, we again make the particular function call. See, the value of local variable is 4, and now we are inside another function call. If I will go back to this particular function call, our this previous function call, we have its own local variable n with its own value there, right? Value 5, local variable n. Now, as we move forward, the value of n will decrease, right? 3, the value will be 2, the value will be 1. See, right now the value is 1. By making these many function calls, right now we are standing in a function where the value of n, where the particular value of n is 1, right? After this function, we are again going to call a recursive function call, but for that particular function, what will the value of n? The value of n will be 0, right? Now Let's see what happens if the value of n will become 0. Now the value of n becomes 0. Watch this particular call stack, right? Value of n is 0. We encounter the return statement. We will go back to the previous recursion. Sorry. See, the one recursion is deleted. The last recursion was deleted. Right now, how many we have? 3 to 5. 5 recursions right now. Okay. So what happens? While getting this n equal to 0, what happens? The function makes a return call. It will return back to this line only, right? From here, this function will return back to some line only. Similar to that, the previous function will return back to this function. This function again return back to this function. This function will return back to this function, and this function will return back to main, right? Now let's observe. So what was the value of n inside this particular function? Okay, so what was the value of n inside this function? That is 1, right? So see, the value of n is 1. Now we will go back one previous. See, we have only 4 recursion, 4 function calls left. What was the value of the function? 2. Now we will go back one more step. The value of n is 3. Now we are at recursion number 3. Similarly, we'll come back to the last recursion. Then we will go back to this particular function. See, again, n is deleted, right? So n only exists inside its owner, right? That particular n is known as local variable, right? Now go back, that's it. The function ends, memory will clean itself, right? Okay. So this is how a particular function recursion call will work. The concept of global local variable, right? The concept of a base condition in recursion. Okay. Okay, just take a 2-minute break, right? Okay, guys, let's continue then. What we have function calls, right? Okay. So this concept of recursion is a tricky one, right? It is very hard to, I mean, for beginners, it is very hard to construct a good recursion call, right? And you will see the use case of this recursion calls when you will study some recursive algorithms in DSA, right? Okay. Other than that, this recursion are common for each and every language. C++, there is a function recursion call. So this recursion, consider this recursion as a concept of a language, right? It is common to all language, right? Okay. Seen recursion, we have seen function calls right now. Let's see one good example of how to use recursion, right? Okay, we have seen an example of recursion. So how to print a number in reverse order from 5 to 1, right? This is a number. Okay, now let's use recursion to calculate factorial of a number, right? So if you don't know what is a factorial is, So factorial of n, okay, let's factorial of 4 is considered as 4 into 3 into 2 into 1. This is what factorial is considered as, right? Now, why this problem? So if you have noticed that we are not returning any particular value in our previous recursion call. Right now, let's see an example where, see, in all these recursive calls, yeah, in all this recursive call, when we are returning back to our functions, we are not carrying any value, right? We are not carrying any value. Okay. So let's see how to carry a particular value in recursion, right? So actually this particular is known as recursion stack, and let's see how to carry a value in up above the recursion stack, right? Okay. Our aim is to achieve factorial somewhat similar to this one only, right? One more very common example of a recursion is Fibonacci series, right? Okay, now let's focus in our example only right now. Then that instead of this, let me create a particular answer variable. What this answer will collect? So this answer will collect the particular value multiplication of n. See how I will use a particular global variable here, right? I am creating a global variable here, right? This answer will be considered as a global variable. Why? Because it is written outside the function. Okay. So this variable will be accessed by this function, right? Okay. We have one. So there is no multiplication for 0, right? So at this is again our base case. We at n double equal to 0, we have to return, right? Let's make a factorial call. Suppose I want the factorial of 4. Okay. Let's start by multiple values to watch. Recursion is good. This is good. Not this one. It's- Yeah. Okay. This will be enough. For this time, right? Add one more watch. That will be answered. Okay. We are at line number 2. Right now, answer is not declared, but after executing line number 2, we have an answer. A variable answer is there, right? Okay. Now come to line number 10. See, we have a variable answer equal to 1. Okay. Now we are in the function call is made. The value of n is 4. See, inside that function also there exists a variable named as answer, right? There exists a variable. Okay. Now guys, see, when coming back to our function call, our answer is also listed inside the local variable only, right? So the this concept of global and local is only the concept of the scope from where you are seeing that particular variable. Okay, let me explain this one again. So this particular answer is a global variable, a global variable. Why? Because this function can access that particular variable. Some other function, if there may exist some other functions, those function can again access that particular variable. But suppose consider a condition where we have a function defined inside another function. Suppose it is a temporary function, right? A function defined inside another function. Okay, you can do this also, right? No, no error. You will get no error for that. It is fine. Okay, so this n is created for this whole block, this whole function. So for this temporary function, this n will act as a global variable, right? So if you can describe a variable as a global variable or a local variable, it depends on the scope where that variable is defined and you are asking for which function. If I will ask for this recursive function, this n is a local variable. But if I will ask for you this temporary function, this n is a global variable for that temporary function, right? So global and local is only dependent on your scope from where you are asking for which perspective you are asking that variable is, right? Okay. So the value of n is 4. We are multiplying that and n to answer. The value of answer will update, right? Oh, why return? We are getting a return. Okay, let's end this one. See what happened. This particular answer is right now considered as a local variable here, right? So just wait a second. Don't think we have enough time left right now. Okay, we are getting this thing. This. Okay, okay, okay. So guys, this is a way to access global variable, right? I just forgot to write a particular statement here. Okay, whenever you are referencing to a global variable in any scope, if you want to access a global variable, use the keyword global, right? So it describes that this particular answer, it is a global variable, right? Okay, okay. I just missed that one. So this answer is treated as a local variable inside the function. Okay, just let's quickly uh, end this one. So the answer value is 1. We are making a function call. Up till now, our global variable answer is created, but no value for n is created right now. Okay. Inside the function, we have a value of n. We have a answer value. We are using answer as a global variable here, right? So we have to tell the function that use the global variable answer. Okay. So see, observe the value of this answer. The answer will become 4, right? After that, we will make one more function call. See the call stack. There is one more function call. Right now, the value of n will be 3. Why? Because we are making a function call with n minus 1, right? Okay. The value is 3. Again, check the condition. No change. We will multiply the value. Our current answer value is 12, right? Again, we will change the value to 3 minus 1. That will be 2. The value of n is 2. There is again one more function call. A stack is there, right? The value will be multiplied, we will get the values, and again the value of n equal to 1 is multiplied. See, our aim is to achieve the factorial, that is 4 into 3 into 2 into 1. We are saving that value in a new variable named as answer, right? A global variable. Okay. So what is so as you can observe that the value of global variable does not depend on your function, your local function, right? This function can control this n. This function can control this particular n. But if a global variable, suppose a global variable a is defined there, so your function does not control the value of this a, right? You can perform operation on that a, but your function cannot control this answer, right? Because answer is a global variable. This answer is common to all, right? This answer is common to this answer is common to this function, this answer is common to this function, this answer is common to this function. There is no separate copy of answer for each and every function. Like n, there is a separate copy of n for each function. But as you can see, the answer remains 24 because it is a global variable shared by each and every function, right? So that is the use of a global variable. Now, a last function call n will be 0. We will strike the return and the return will work. The stack will get empty, right? One by one. And the answer is 24. That is our factorial of 4. So you can add a print statement here to print the value of answer. That's good, right? So this is how a stack will function, recursion will work, right? I will get the value as 24. Okay. So that's it for today, guys. Tomorrow we are going to discuss about a very important topic in Python, that is known as OOPS concept, object oriented programming, right? That is, you can say 50% theory based and 50% coding is there, right? Okay. So see you tomorrow then.